To solve real-world problems that compare proportional relationships, we can create a proportion that contains a variable for that unknown quantity. Next, we can cross-multiply, which will create an equation. From there, we can solve our equation using inverse operations, and this will help us find the unknown quantity. So let's look at an example. This problem says Leila and Joe are two of the partners in a business. Leila makes $3 in profits for every $4 that Joe makes. If Joe makes $60 profit in the first item they sell, how much profit does Leila make? For this problem, we see that Leila makes $3 profit, so we can say Leila makes $3 for every $4 that Joe makes. So the proportion that would represent this is $3 to $4. And $3 represents the profit for Leila, $4 represents the profit for Joe. I can make a proportion by setting this equal to another ratio, and in this ratio, I know that Joe makes a $60 profit. So since Joe is in my denominator on my first ratio, I'm going to put Joe in my denominator for my second ratio. What I don't know is how much profit Leila makes. Since I don't know that value, I'm going to use a variable to represent it. Now, there are different ways that we can do this. Previously, you've learned that I know that if I'm moving from 3 to x, I can figure out how I moved from 4 to 60. I know that to get from 4 to 60, I would multiply 4 times 15. And since this is changing at a proportional rate, I would also multiply 3 times 15 to get x. Sometimes we have values that aren't that friendly, and they are a little bit difficult to do things like that with. So, in those cases, we can cross multiply and make an equation. When we cross multiply, we start with the numerator from the first ratio and multiply it by the denominator in the second ratio. So we would multiply 3 times 60 to get 180. Then we would write an equal sign. Next, we would multiply the numerator from the second ratio by the denominator in the first ratio. So x times 4 would give us 4x. Now, all we would need to do is solve for x using inverse operations. Since x is being multiplied by 4, I know that I need to divide by 4 on both sides of my equation. If I divide by 4, 180 divided by 4 will give me 45. These 4's will cancel and leave me with x. This means that if Joe makes a $60 profit, Leila makes a $45 profit. Next, I see that contestants in a dance-a-thon rest the same amount of time every hour. A couple rests for 25 minutes in 5 hours. So how long did they rest in 8 hours? Well, the first thing I can do is make my first ratio. From my first ratio, I know that the couple rests 25 minutes in 5 hours. So the couple rests for 25 minutes in 5 hours. That's my first ratio. Now I'm trying to find how long they rested, and since rested is in my numerator for my first ratio, I'm going to put that in my numerator for my second ratio. And since I don't know it, I'm going to put a variable. What I want to find out is how long they rested if they danced for 8 hours. Since hours are in my denominator for my first ratio, they're going to be in the denominator for my second ratio. Now, I can't easily see how I moved from 5 to 8, so this is one of those situations where using cross multiplication would actually help us. So I would multiply 25 times 8, which would give us 200. And then I would put my equal sign. Then I would multiply x times 5, which would give us 5x. Now, to get x by itself, I would divide by 5 on both sides of my equation. 200 divided by 5 is 40. My 5 divided by 5 is 1, and 1x leaves us with just x, so the 5's cancel. This means that x equals 40, so the couple rests 40 minutes in 8 hours. Next, I see that Frances gets 6 paychecks in 12 weeks. How many paychecks does she get in 1 year? Well, let's start with what we know first. We know that she gets 6 checks in 12 weeks. The question wants to know, how many paychecks does she get in 1 year? The problem is when I compare my first ratio is comparing checks to weeks. Neither of those are in years, which means if I want to put 1 year into my second ratio, I need to convert the year into weeks. Well, I'm going to use what I know about years. I know that 1 year is equal to 52 weeks. Since 1 year is equal to 52 weeks, I'm going to put 52 in the denominator of my second ratio. What I don't know is how many paychecks Frances gets, so I'm going to put that here. Now I can cross multiply, so I'll multiply 6 times 52, which gives me 312. Then I put my equal sign. I multiply x times 12, which is 12x. Now I'm just going to get x by itself by dividing by 12 on both sides of my equation. 312 divided by 12 is 26. My 12 divided by 12 is 1, which leaves me with 1x, or just x. This means that Francis gets 6 paychecks in 12 weeks. That means that he gets 26 paychecks in 1 year, or 52 weeks. In a repeating musical pattern, there are 56 beats in 7 measures. How many measures are there in 104 beats? So let's start with what we know. We know that there are 56 beats in 7 measures, so we can make a ratio out of that to show 56 beats for every 7 measures. Now I want to know how many measures. So in this case, I do not know how many measures. Since measures are in my denominator over here, I'm going to put a variable for measures in my denominator on my second ratio. This time I know that there are 104 beats, so I'm putting 104 beats in the numerator. And now I can cross multiply. I'm going to multiply 56 times x, which would give me 56x, and then I put my equal sign. Then I'm going to multiply 104 times 7, which would give me 728. Now to get x by itself, I'm going to divide by 56 on both sides. My 56 will cancel, which will leave me with x equals, and then 728 divided by 56 is 13. This means that there are 13 measures in 104 beats. Hendrik wants to enlarge a photo that is 4 inches wide and 6 inches tall. The enlarged photo keeps the same ratio. What is the area of the enlarged photo if it is 12 inches wide? So the photo is enlarging at the same rate, so we're going to start with the original photo. Our original photo was 4 inches wide and 6 inches tall, so that's going to be our first ratio. It's 4 inches wide to 6 inches tall. Next, we know that we are looking for an enlargement that makes it 12 inches wide. Since my wide is on my numerator for my first ratio, width is going to be in my numerator for my second ratio. What I don't know is how tall that enlarged photo will be, so I'm going to put a variable to represent that. Now, for this one, I can see that if I move from 4 to 12, I can pretty easily see that I can multiply 4 times 3 to get to 12, which means I would also multiply 6 times 3 to get to x. So I can see that x would be 18. But if you can't see that, or if you just prefer using cross multiplying to solve your proportion, you can do that here. 4 times x would give me 4x. 12 times 6 would give me 72. And then I would divide by 4 on both sides of my equation. My 4's would cancel and leave me with x equals, and 72 divided by 4 is 18. So that means that this photo is 18 inches tall. However, if you look at the question doesn't ask how tall the photo is. The question asks what is the area of the enlarged photo. Well, we know that if we have a photograph, if it's 12 inches wide and 18 inches tall or long, it would look like this. So it is in the shape of a rectangle. To find the area, we would need to use the formula for the area of a rectangle, which is base times height, or length times width. So to find the area here, we're going to multiply 12 times 18. When I multiply 12 times 18, I get 216. So the area of this enlarged photograph is 216 square inches.